The car sliding down the ramp exemplifies Newton's first law of motion, because even though the car is on a decline and should be increasing its velocity, it isn't. The car actually slows down near the end of the track due to an outside force, friction, acting on it and slowing it down. This proves Newton's first law that states an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an outside force. Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. This is shown in my project as the large marble sliding down the big ramp, knocking the blocks away, allowing for the Newton's cradle ball to fall. I knew I needed to have lots of force in order to knock those blocks away with a marble. After testing, I saw that a smaller marble was not enough. I increased the force by increasing the mass of the marble, and the heavier marble was able to knock the blocks away, allowing the Newton's cradle ball to fall. As the car rolled down the track, it hit the domino which stopped it. As the car stopped, the domino fell over. This was a transfer of force. The car projected its force on the domino when it hit it, and the domino pushed back, stopping the car. This is in accordance with Newton's third law of motion, which says that every action has an equal and opposite reaction. The car pushed the domino, and the domino pushed back. The law of conservation of energy states that the energy of interacting bodies or particles in a closed system remains constant. This is seen when the two jacks, which were sitting still, had no kinetic energy at all, only potential energy, which was equal to their mass times gravity times its height. As it was struck, it started to fall. Not all the potential energy went away, as the system was still above the ground, thus it still had height. But the system's potential energy was decreasing along with its height. The potential energy that was no longer there had turned into kinetic energy, its speed falling towards the ground. In any collision occurring in an isolated system, momentum is conserved. The total amount of momentum of the collection of objects in the system is the same before the collision as after the collision. When the first ball of a Newton's cradle collides with the second, the first ball stops, but the momentum isn't lost. It is just transferred to the second ball, then the third, then the fourth, until it reaches the very last ball. We see the momentum of the last ball swinging out with nearly the same momentum as the first ball.